My name is Professor Michio Kaku. I'm a professor of theoretical physics at the City University of New York, and I specialize in something called string theory. And today, I need to tell you something that will fundamentally change how you think about humanity's place in the universe. For decades, we've been searching for alien civilizations. We've been listening for radio signals with SETI, the search for extraterrestrial intelligence. We've been looking for signs of advanced technology. Megastructures around distant stars, artificial lights on exoplanets, anything that might indicate we're not alone in the cosmos. And we found nothing. Absolute silence. No signals, no structures, no evidence whatsoever of other technological civilizations. This absence has puzzled scientists for decades. It's called the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody? The universe is vast and old. There are hundreds of billions of galaxies, each containing hundreds of billions of stars. Many of these stars have planets. The numbers are staggering. There should be countless opportunities for life to emerge, for intelligence to evolve, for civilizations to develop, and yet we see nothing." But I'm not here to talk about why we haven't detected aliens yet. I'm here to tell you why we never will. Not because aliens don't exist. They probably do. Possibly millions of civilizations scattered across the galaxy, but because the universe is structured in such a way that intelligent species can never meet each other, not due to lack of trying, not due to insufficient technology, but due to fundamental physical and biological constraints that make contact between civilizations literally impossible. The distances are too vast. The timescales are too long. The energy requirements are too extreme. The biological incompatibilities are too severe. And most fundamentally, the speed of light is too slow. These are not engineering problems that better technology can solve. These are fundamental limitations built into the structure of the universe itself. We are not just isolated from alien civilizations by distance and time. We are permanently, irrevocably isolated by physics. The universe has scattered consciousness across vast gulfs of space and time, and those gulfs cannot be crossed. We will never meet aliens. They will never meet us. We are all alone, forever, by cosmic design. Let me start with the most fundamental barrier, the speed of light. Einstein showed us that nothing can travel faster than light, about 300,000 kilometers per second. This is not a technological limitation. It's a fundamental law of physics built into the structure of space-time itself. As you approach the speed of light, your mass increases toward infinity, requiring infinite energy to accelerate further. The speed of light is the ultimate speed limit of the universe, unchangeable and absolute. Now, 300,000 kilometers per second sounds fast. Light can circle Earth 7 times in 1 second. But the universe is incomprehensibly vast. The nearest star to our sun is Proxima Centauri, 4.2 light years away. That means light takes 4.2 years to travel from Proxima Centauri to Earth. A radio signal we send today won't arrive there until 4.2 years from now. And their response wouldn't reach us for another 4.2 years. That's an 8.4-year round-trip communication delay for the very nearest star. Most stars are much farther. The average distance between stars in our region of the galaxy is about 5 light years. The galaxy itself is about 100,000 light years across. And other galaxies? The nearest major galaxy, Andromeda, is 2.5 million light years away. These distances are so vast, they're almost incomprehensible. If you could travel at the speed of light, which you can't, it would take 4.2 years to reach the nearest star, decades to reach more distant stars, thousands of years to cross the galaxy, millions of years to reach other galaxies. But no physical object can travel at light speed. Even light speed travel is impossible for anything with mass. The fastest speed realistically achievable with any propulsion system we can imagine, nuclear fusion rockets or matter-antimatter engines, is maybe 10% of light speed. And that's wildly optimistic, probably not achievable for centuries, if ever. More realistic estimates for advanced propulsion are 1 to 5% of light speed. At 10% light speed, reaching Proxima Centauri takes 42 years. At 1% light speed, it takes 420 years. That's longer than the United States has existed as a nation. And Proxima Centauri is our nearest neighbor. Reaching stars 50 or 100 light years away would take thousands of years, even at optimistic speeds. Crossing the galaxy would take hundreds of thousands of years. And traveling to other galaxies? Millions of years. These are timescales far exceeding human lifespans, exceeding the duration of civilizations, possibly exceeding the evolutionary timescales of species. So even if aliens exist, even if they're out there right now in nearby star systems, the distances make contact effectively impossible. We could send radio signals and wait decades for a response. We could send probes that would arrive centuries from now. But actual meeting, actual face-to-face contact, actual cultural exchange and interaction, that requires travel. And travel at these distances is impossible in any meaningful sense. Now, some people bring up generation ships, spacecraft that take centuries to reach their destination, with multiple generations living and dying aboard during the journey. And yes, you could theoretically build a generation ship, but as I've discussed before, generation ships face insurmountable problems. Life support must work perfectly for centuries with no resupply. Social cohesion must be maintained across generations of people who never chose the mission. The destination must be worth the journey, despite having no information about it beyond centuries-old telescope observations. And even if you could solve all these problems, even if you could send a generation ship to a star 100 light years away, the journey would take thousands of years at realistic speeds. By the time your ship arrives, Earth civilization might have collapsed. The language and culture your crew carries might be ancient history. The aliens they're going to meet might have evolved or gone extinct. The whole enterprise becomes absurd when you consider the timescales involved. And this assumes aliens are in nearby star systems. What if the nearest civilization is 1,000 light years away, or 10,000 light years? Then travel becomes impossible even with generation ships. You'd need vessels that function for tens of thousands of years, maintaining human populations for hundreds or thousands of generations. That's not a spaceship, that's a mobile civilization, and it's completely impractical. So the speed of light and the vast distances between stars create the first insurmountable barrier to meeting aliens. Even if they exist, even if they're relatively nearby in cosmic terms, the distances are too vast for meaningful contact. Now let me talk about the second fundamental barrier: time. Not just the time it takes to travel, but the temporal distribution of civilizations. The universe is 13.8 billion years old. Our galaxy formed about 13 billion years ago. Stars have been forming and dying for billions of years. Planets have been forming for billions of years. Life on Earth emerged about 3.8 billion years ago. Multicellular life appeared about 600 million years ago. Humans evolved about 300,000 years ago. Technological civilization emerged about 10,000 years ago. We've had radio technology for about 120 years. We've had spaceflight for about 65 years. In the 13.8 billion year history of the universe, we've been capable of detecting alien signals for 0.00001% of that time. We are infants in cosmic terms. Now, other civilizations would have their own timelines. They emerged at different points in galactic history. They developed technology at different rates. They might exist for different durations before going extinct. Some might have emerged billions of years ago and already died out. Others might emerge millions of years in the future. The probability that two civilizations exist at the same time in the same region of the galaxy, both at technological stages where they can detect each other, is incredibly small. It's like two ships passing in the night across an ocean, except the ocean is billions of years deep and the ships are separated by thousands of light years. You might have signals crossing in space but never overlapping in time. Or you might be looking for signals from a civilization that won't exist for another million years. Or receiving signals from a civilization that died out millions of years ago. The temporal problem is even worse than the spatial problem. Space is vast, but at least it exists all at once. Time is sequential. Two civilizations separated by a million years might as well be in different universes because they cannot interact causally. They cannot influence each other, cannot communicate, cannot meet. The universe could be full of civilizations scattered across billions of years of galactic history, and they would all be completely isolated from each other by time. Let me give you a concrete example of how this works. Let's say there's an alien civilization around a star 1,000 light years from Earth. They're currently at our level of technology, capable of radio communication and interested in finding other civilizations. They're broadcasting signals into space right now. Those signals are traveling at the speed of light. They will reach Earth in 1,000 years, around the year 3025. But will human civilization still exist in 3025? Will we still be listening for alien signals? Will we be using radio technology, or will we have moved on to something else? Will Earth be habitable, or will climate change have made it uninhabitable? Will humans even exist as a species, or will we have evolved into something else or gone extinct? We don't know. Similarly, the signals we're broadcasting now will reach that alien civilization in the year 3025 by their calendar. Will they still exist? Will they still be listening? Or will they have destroyed themselves through war or environmental collapse? Or evolved beyond the need for radio? The probability that both civilizations exist and are listening at exactly the right time to receive each other's signals is incredibly low. And that's assuming only 1,000 light years of separation. For civilizations separated by 10,000 or 100,000 light years, the temporal coordination problem becomes impossible. You're trying to communicate across tens or hundreds of thousands of years. The civilization that receives your signal might be as different from the civilization that sent it as modern humans are from Homo erectus. They might not even recognize it as an intentional communication. So the combination of spatial distance and temporal coordination creates a double barrier to contact. Two civilizations might exist in the same galaxy, but be separated by enough distance and time that they can never communicate meaningfully. They might overlap in space, but not time, or overlap in time, but be too far apart in space. The universe has scattered civilizations across both space and time in such a way that contact is vanishingly unlikely. Now let me talk about the third barrier, energy requirements. Even if you could build a spacecraft, even if you could solve the generation ship problems, even if you found a destination worth traveling to, the energy required for interstellar travel is astronomical. Literally. Let's do some calculations. Suppose you want to send a spacecraft to Proxima Centauri, 4.2 light years away, at 10% light speed. That's 30,000 kilometers per second. The kinetic energy of a moving object is 1/2 mass times velocity squared. For a spacecraft with mass of, say, 1,000 tons, that's 1 million kilograms, moving at 30 million meters per second. The kinetic energy works out to 450 trillion megajoules. That's about 450 exajoules. To put that in perspective, the total energy consumption of all human civilization in a year is about 600 exajoules. So accelerating a 1,000-ton spacecraft at 10% light speed requires energy equivalent to most of a year's worth of all human energy consumption. That's just to accelerate. You'd need the same amount of energy to decelerate at the destination. So round trip, you're looking at 2 years worth of total human civilization energy output just to send one moderately sized spacecraft to the nearest star at 10% light speed. And that's assuming perfect efficiency, which is impossible. Real propulsion systems have efficiencies well below 100%. You'd probably need 10 times that energy in practice. And you'd need to carry the fuel with you, which increases the mass, which increases the energy requirements further. The rocket equation makes this exponentially worse. To carry enough fuel to accelerate and decelerate a spacecraft, you need vastly more fuel than the spacecraft mass itself. And that fuel has mass that requires even more fuel to accelerate. It's a vicious cycle that makes the energy requirements exponentially larger as you try to go faster or farther. This is why interstellar travel is not just difficult, but genuinely impossible with any foreseeable technology. The energy requirements are simply too extreme. You'd need to harness energy on the scale of a star to send meaningful numbers of spacecraft to nearby stars. You'd need Dyson spheres or similar megastructures capturing the total output of stars. And even that might not be sufficient for travel to distant stars or for sending large payloads. So energy creates another fundamental barrier. Even civilizations far more advanced than ours, even civilizations millions of years more advanced, would struggle with the energy requirements of interstellar travel. And this assumes they've solved all the other problems like propulsion, life support, navigation, and communication across light years. The energy barrier alone might be sufficient to confine all civilizations to their home star systems. Now, let me talk about detection, about the problem of actually finding alien civilizations, even if they exist. SETI has been searching for alien radio signals since 1960. That's over 60 years of listening, and we found nothing. No artificial signals, no repeated patterns, no evidence of intelligent communication. Why? Well, first, radio signals weaken with distance. They spread out as they travel, following the inverse square law. A signal that's detectable at 1 light year is 4 times weaker at 2 light years, 9 times weaker at 3 light years, and so on. By the time a signal has traveled 100 light years, it's 10,000 times weaker. By 1,000 light years, it's 1,000,000 times weaker. Eventually, the signal becomes indistinguishable from background noise. Even powerful transmitters become undetectable beyond a few hundred light years at most. Second, we might be looking at the wrong frequency or using the wrong technology. We're searching for radio signals, because that's what we use, but aliens might communicate using something completely different. Laser pulses, neutrinos, gravitational waves, technologies we haven't even imagined. If they're using communication methods we don't recognize, we could be receiving their signals constantly and not even know it. Third, advanced civilizations might not use radio at all. We've only been using radio for about 120 years. In another century, we might move to something else entirely. Fiber optics, quantum entanglement communication, directed narrow beam transmissions that don't leak into space. If aliens are even slightly more advanced than us, they might have stopped using radio millions of years ago. We'd be searching for signals they stopped sending long before Earth even formed. Fourth, even if aliens are broadcasting, they might not be broadcasting toward us. Space is three-dimensional. If you want to send signals to every direction, you need enormous power. Most likely, civilizations would use directed beams towards specific targets. If they're not aiming at Earth, we won't receive their signals, no matter how powerful they are. Fifth, the timing has to be exactly right. If aliens broadcast for 100 years and then stop, we have to be listening during exactly those 100 years. If they broadcast 1,000,000 years ago, their signals have already passed us by. If they'll broadcast 1,000,000 years from now, we're too early. The window of overlap is tiny. So detecting alien civilizations, even if they exist and are trying to communicate, is incredibly difficult. It requires that they exist at the right time, at the right distance, using the right technology, broadcasting in our direction, and us listening at exactly the right moment. The probability of all of these factors aligning is infinitesimal. This is why SETI has found nothing despite decades of searching. It's not that aliens don't exist, it's that detecting them is nearly impossible. Now let me talk about biological incompatibility, because even if we could reach aliens, even if we could travel to their worlds or they could travel to ours, there's another fundamental barrier. We probably couldn't survive in each other's environments, and we might not even be able to breathe the same air or eat the same food. Life on Earth is all related. Every organism, from bacteria to humans, shares common biochemistry. DNA, RNA, proteins, the same 20 amino acids, the same basic cellular structures. This is because all life on Earth descended from a common ancestor that existed billions of years ago. But alien life, if it exists, would have evolved completely independently. It would have different biochemistry, possibly using different molecules, different genetic codes, different cellular structures. It might not even be carbon-based. It could be silicon-based or use entirely different chemistry. And even if aliens are carbon-based and use similar biochemistry, they evolve on a different planet with different conditions, different gravity, different atmosphere, different temperature, different radiation environment, different day-night cycles. Every aspect of their biology would be tuned to their home planet's specific conditions, just as ours is tuned to Earth. So if we went to their world, we probably couldn't breathe their air. The oxygen content might be too high or too low or non-existent. There might be gases toxic to us. The atmospheric pressure might be wrong. The temperature might be extreme. The gravity might be crushing or insufficient. We'd need spacesuits and habitats just to survive, exactly as we would on Mars or any other planet. Similarly, if aliens came to Earth, they probably couldn't survive here. Earth's atmosphere might be toxic to them. Earth's gravity might be wrong. Earth's microbes might be deadly pathogens they have no immunity to. They'd need their own spacesuits and habitats. So even if we could meet, we'd be meeting inside artificial environments, isolated from each other by biology. We couldn't shake hands, couldn't share meals, couldn't experience each other's worlds directly. We'd be forever separated by spacesuits and glass barriers. That's not the meeting of civilizations that science fiction portrays. That's quarantine. That's biology, recognizing that organisms from different worlds are incompatible and keeping them apart for mutual safety. And there's an even deeper problem: communication. Human language evolved from human cognition, which evolved from primate cognition, which evolved from mammalian cognition, which ultimately traces back to the specific evolutionary history of life on Earth. Our concepts, our ways of thinking about reality, our sensory experiences, all are shaped by being human organisms that evolved on Earth. Alien cognition would be completely different. Aliens would perceive reality differently, think differently, have completely different concepts and categories. How do you communicate with a being that doesn't share any of your evolutionary history, any of your sensory experiences, any of your conceptual frameworks? Even if you could transmit information back and forth, what would you actually communicate? Mathematics, perhaps. Physics. But anything more complex, anything involving culture or values or subjective experience, would likely be untranslatable. We'd be mutual mysteries to each other, unable to understand each other's thoughts or motivations or meanings. So biological and cognitive incompatibility creates yet another barrier. Even if all the physics problems could be solved, even if we could somehow meet aliens face to face, we'd be separated by biology in ways that might make meaningful interaction impossible. In part 2, I'm going to examine specific scenarios that people propose for making alien contact and show you why each one fails. Radio communication across interstellar distances, interstellar probes, generation ships, all the methods people propose for meeting aliens turn out to be impossible when you run the numbers honestly. And I'll explain why the Fermi Paradox is not a paradox at all. It's exactly what we should expect in a universe where the laws of physics make contact between civilizations impossible. The universe is full of life, full of intelligence, but it's structured in such a way that we can never meet. We are alone. Not because we're the only ones, but because meeting is impossible. That's the real answer to where is everybody. They're out there, but we can never reach them, and they can never reach us. We were never meant to meet them. So we've established the fundamental barriers: the speed of light, the vast distances, the temporal coordination problem, the energy requirements, the detection difficulties, and the biological incompatibilities. Now let me take you through the specific methods people propose for making contact with aliens and show you exactly why each one fails when you examine it honestly. Because there's always someone who says, but what about this approach? Or couldn't we just do it this way? And the answer is always no. Every method fails. Every path to contact leads nowhere. Not because we're not clever enough, but because the universe doesn't allow it. The laws of physics, the structure of space-time, the nature of biology, all conspire to keep civilizations isolated. Let me show you why. Let's start with radio communication via SETI, because this is what we've been doing for over 60 years and what most people think of when they imagine contacting aliens. The idea is straightforward. We broadcast radio signals into space announcing our presence, and we listen for similar signals from aliens. If they're out there broadcasting, we'll detect their signals. If they're listening, they'll detect ours. Eventually, we establish communication. We can't meet physically, but we can exchange information, learn about each other, share knowledge. That sounds reasonable until you examine the details. First, let's talk about what we're actually broadcasting. Earth has been inadvertently broadcasting radio and television signals into space since about 1900. These signals leak into space from commercial broadcasts, military radar, TV transmissions, all the electromagnetic noise of technological civilization. This creates an expanding sphere of radio signals centered on Earth, growing at the speed of light. Currently, that sphere has a radius of about 120 light years. Any alien civilization within that sphere with sufficiently sensitive receivers could theoretically detect our signals and know we exist. But here's the problem. Those signals are incredibly weak. They're not directed beams aimed at specific targets. They're omnidirectional broadcasts that spread out in all directions. The power decreases with the square of the distance. By the time our TV signals have traveled 100 light years, they're so weak they're essentially indistinguishable from background cosmic noise. You'd need a radio telescope the size of a planet to detect them. So our inadvertent broadcasts are probably undetectable beyond maybe 50 light years at most. And that's being optimistic. Within 50 light years of Earth, there are only about 1,400 stars. If we assume 10% have planets and 1% of those have civilizations, that's maybe 1 or 2 civilizations within detection range. And that's if civilizations are common, which they might not be. Now, we could broadcast much more powerful directed signals aimed at specific stars. In fact, we've done this a few times. In 1974, we broadcast the Arecibo message toward the globular cluster M13, about 25,000 light years away. The message will arrive in about 25,000 years. If anyone's there and they respond immediately, we'll receive their reply in 50,000 years. That's longer than modern humans have existed. See the problem? Even if everything works perfectly, even if there's a civilization in M13 that receives our message and responds, the round-trip communication time is 50,000 years. That's not communication. That's sending a message in a bottle and hoping someone eventually finds it long after your entire civilization is dust. And that assumes the target civilization exists now, is listening, recognizes the message as artificial, and cares enough to respond. Those are huge assumptions. For closer targets, the problem is only slightly better. If we broadcast to a star 100 light years away, the round-trip time is 200 years. send a message today, receive a reply in the year 2225. That's longer than the United States has existed as a nation. You could have a conversation, but it would take multiple human lifetimes for each exchange. Hello, we exist. 200 years later, hello, we exist too. 200 years later, what's your planet like? 200 years later, mostly ocean. What's yours like? You get the idea. This is not meaningful communication. By the time you receive a reply, the people who sent the original message are long dead. The political situation that motivated the message has changed. The technology has advanced. The culture has evolved. You're communicating with ghosts of the past. And this assumes the aliens are listening at the right frequency, using compatible technology, and able to decode our messages. Radio covers a huge range of frequencies, from kilohertz to gigahertz. We're broadcasting on certain frequencies, but aliens might be listening on completely different ones. It's like trying to have a phone conversation where you don't know each other's phone numbers and the phone book has billions of entries. You could spend centuries trying different frequencies and never connect. Even if you're on the same frequency, you need to decode the signal. Our messages are compressed, modulated, encoded in ways that make sense to humans but might be completely opaque to aliens. They might receive our signals but interpret them as natural noise rather than artificial communication. We might do the same with their signals. SETI has been listening for over 60 years using increasingly sensitive equipment, scanning millions of frequency channels, analyzing billions of signals, and we found absolutely nothing that looks artificial. The famous wow signal from 1977 was interesting, but never repeated and probably wasn't alien. Everything else has been false alarms or natural sources. 60 years of searching, thousands of stars examined, and complete silence. What does this tell us? Either aliens don't exist within detectable range, or they're not broadcasting, or they're broadcasting in ways we can't detect. All three possibilities suggest that radio communication is not a viable path to contact. Now, let me talk about optical SETI, searching for laser pulses rather than radio signals. The idea is that advanced civilizations might use powerful lasers to send signals because laser light is more focused and can travel farther than radio without spreading out as much. And we should be looking for brief, intense flashes of laser light coming from other star systems. This addresses some of the problems with radio SETI, but it faces its own insurmountable issues. First, laser signals still weaken with distance. Even tightly focused laser beams spread out due to diffraction. A laser pulse sent from 1,000 light years away would be spread over millions of square kilometers by the time it reaches Earth. It would be incredibly faint and difficult to detect. Second, you need perfect aim. Radio signals spread in all directions. So even if you're not aiming exactly at the target, they might still detect you. But laser beams are narrow. If you're off by even a tiny fraction of a degree, you miss completely. Aiming a laser at a planet 1,000 light years away and hitting it requires knowing exactly where that planet will be 1,000 years from now, accounting for orbital motion, stellar motion, galactic rotation. That's incredibly difficult. Third, and this is the killer, you have to be looking at exactly the right place at exactly the right time. Unlike radio signals, which can be detected by large dishes scanning the whole sky, optical signals require you to be pointing a telescope at the exact star at the exact moment the laser pulse arrives. If the pulse lasts 1 second and you're not looking at that star during that 1 second, you miss it completely. Given that there are billions of stars and you can only look at one at a time, the probability of catching a brief laser pulse is essentially zero. Optical SETI has been searching for years and found nothing. For the same reasons radio SETI has found nothing. The universe is too big, the signals are too weak, the timing and targeting requirements are too precise, and aliens probably aren't broadcasting anyway. Now let's talk about interstellar probes. The idea of sending robotic spacecraft to nearby stars to search for life and civilizations. If radio communication doesn't work because of distance and time delays, maybe we can send physical objects that actually travel to other star systems, explore them, and send back information. This sounds more promising than radio communication because probes can gather detailed information once they arrive. But it faces the same fundamental problems we discussed earlier, plus additional ones. First, speed. Our fastest current spacecraft, Voyager 1, is traveling at about 17 kilometers per second relative to the Sunday. At that speed, reaching Proxima Centauri would take about 75,000 years. That's 3 times longer than recorded human history. We could build faster probes. Various proposals exist for nuclear propulsion, fusion drives, laser-pushed light sails, all of which could theoretically reach 10 to 20% of light speed. At 10% light speed, Proxima Centauri is 42 years away. That's marginally better. You could send a probe and receive data back within a human lifetime if you're young when you send it. But building a probe that can travel at 10% light speed is extraordinarily difficult. The energy requirements are enormous, as I calculated earlier. You need to accelerate the probe, and you need to decelerate it when it arrives if you want it to study the target system rather than just flash through at high speed. That doubles the energy requirement. Alternatively, you could use a flyby mission that doesn't decelerate, but then you only get a few hours or days to study the system as you zip through. And communication back to Earth is difficult because you're moving away from both Earth and the target system at high speed. The communication distance increases rapidly. So you really need deceleration, which means you need fuel for deceleration, which increases the mass, which increases the energy needed for initial acceleration. It's the rocket equation problem again. The fuel requirements grow exponentially. Now, suppose we solve all the engineering problems and send a probe to Proxima Centauri. It takes 42 years to get there. It studies the system for a few years. It sends data back to Earth. That data takes 4.2 years to arrive. So we're looking at nearly 50 years from launch to receiving information. That's a long time, but not completely unreasonable. The problem is that Proxima Centauri probably doesn't have life. It's a small red dwarf star with a planet in the habitable zone, but that planet is probably tidally locked, constantly bathed in stellar flares, and unlikely to be habitable. So we'd be spending enormous resources to study a system that's probably barren. To find life or civilizations, we need to send probes to many stars, dozens or hundreds of systems, hoping to get lucky. Each probe costs billions or trillions of dollars and takes decades to return data. The total costs would be astronomical and the return on investment questionable. Even worse, by the time a probe launch today reaches its destination 50 years from now, technology will have advanced so much that we could build a faster probe using newer technology that would overtake the original probe and arrive first. This is called the weight paradox in interstellar travel. If technology is improving, it's always better to wait before launching because future probes will be faster and cheaper. You never actually launch because you're always waiting for better technology. This paradox suggests that interstellar probes are not practical for civilizations with advancing technology, which is probably why we haven't detected probes from alien civilizations. They face the same weight paradox and never actually send them. Now let's talk about the idea of self-replicating probes, sometimes called von Neumann probes, after mathematician John von Neumann. The idea is that you send out probes that can replicate themselves using materials found in other star systems. One probe reaches a star, builds copies of itself using asteroids or planets, and sends those copies to other stars. Each generation of probes multiplies and spreads. Eventually, you've explored the entire galaxy with probes. This sounds like a solution to the cost problem, because you only need to build the first generation, but self-replicating probes face enormous technical challenges. You need a probe that can mine asteroids, refine raw materials, manufacture complex components, assemble them into functioning probes, and do all of this autonomously without human supervision because it's light years from Earth. That's far beyond our current robotics and AI capabilities. We can't build self-replicating machines, even in ideal conditions on Earth, let alone in the harsh environment of space, using whatever materials happen to be available. Even if we could build such probes, there are serious dangers. Self-replicating machines could malfunction and become destructive, consuming all available resources, turning star systems into probe factories. This is the gray goo scenario, where self-replicating machines get out of control. It's possible that advanced civilizations deliberately avoid building self-replicating probes because the risks are too high. And even if you solved all the technical problems and sent out self-replicating probes, they take millions of years to spread across the galaxy at sublight speeds. By the time they finished exploring, the civilization that sent them might be extinct. So self-replicating probes don't solve the fundamental problems. They just spread them across more star systems. Now let me talk about generation ships, because this is the ultimate proposal for meeting aliens face to face. If we can't communicate meaningfully due to light speed delays, and probes can't substitute for actual contact, then we need to send humans to other star systems. Generation ships are spacecraft large enough to house thousands of people who live their entire lives aboard, having children who continue the journey with distant descendants, eventually arriving at the destination star system hundreds or thousands of years later. I've discussed generation ships before and explained why they're probably impossible, but let me specifically address them in the context of meeting aliens. Suppose we want to send a generation ship to a star system where we believe aliens exist based on radio signals we've detected. The nearest such system is probably at least 100 light years away, possibly much farther. At 1% light speed, which is optimistic, that's a 10,000 year journey. At 10% light speed, which is wildly optimistic, it's a 1,000 year journey. Let's use the optimistic number. A 1,000 year journey means about 30 to 40 generations living and dying aboard this ship. The people who arrive have no memory of Earth except through historical records. They've spent their entire lives in the artificial environment of a spaceship, and now they're meeting aliens for the first time in human history. What could possibly go wrong? First, the ship has to function perfectly for 1,000 years. Every system, life support, power, propulsion, navigation, communication, all must work for a millennium. We can't build anything on Earth that lasts 1,000 years without extensive maintenance. Spacecraft are far more fragile than Earth structures. They're exposed to radiation, micrometeorites, vacuum, temperature extremes. Systems will fail, equipment will break down, and you can't get spare parts from Earth. You need to manufacture everything aboard the ship, which requires industrial capabilities, raw materials, expertise. Second, the social and psychological challenges are overwhelming. You need to maintain a stable society for 40 generations in complete isolation in an artificial environment, with everyone knowing they're trapped until they die. How do you maintain motivation? How do you prevent social collapse, civil war, mutiny? How do you preserve knowledge and skills across generations? How do you deal with genetic drift in a small population? How do you maintain genetic diversity? These problems might be unsolvable. But suppose you solve them. Suppose your generation ship arrives at the alien star system after 1,000 years. What do you find? Third, the aliens might be gone. The radio signals you detected were sent 1,000 years ago, from their perspective. By the time you arrive, they might have died out, evolved into something unrecognizable, or left their planet. You've traveled for a millennium to meet ghosts. Or worse, the aliens might be hostile. You've spent 1,000 years traveling to meet them, and they see you as invaders or threats. They might attack your ship. They might have weapons technology far beyond yours after another 1,000 years of development. You're vulnerable, far from home, with no backup and no escape. Fourth, Even if the aliens are still there and are friendly, you face all the biological incompatibility problems I discussed earlier. You can't breathe their air, can't survive their gravity or temperature or radiation environment. You're stuck in your spaceship or in artificial habitats you build. The aliens are stuck in their own environment. You meet across barriers of glass and spacesuits, and you probably can't understand each other even with translators because your minds are too different. So what have you actually achieved? You've spent enormous resources, traveled for 1,000 years, sacrificed dozens of generations to live and die in transit, all to establish a presence in an alien star system where you still can't meaningfully interact with the aliens. This is not first contact as portrayed in science fiction. This is quarantine. This is mutual isolation despite physical proximity. And here's the final problem: communications with Earth. You're 100 light years from home. Any message you send takes 100 years to reach Earth. Any response takes 100 years to get back to you. You're having a conversation with 200-year delays. By the time you tell Earth we've arrived and met the aliens, and Earth responds, 200 years have passed. The people who made decisions about your mission are long dead. Earth's civilization might be completely different. They might not care about you anymore. You're essentially on your own, a human outpost 100 light years from home, unable to get meaningful support or guidance from Earth. You're a lost colony in space. So generation ships, even if technically feasible, don't really solve the problem of meeting aliens. They relocate the problem rather than solving it. You still face isolation, communication delays, biological incompatibilities, and all the other barriers. You've just paid an enormous price in time and resources to face those barriers in person rather than from a distance. Now let me talk about some of the more exotic proposals people make for faster-than-light travel. Because someone always says, what about warp drives? What about wormholes? What about quantum entanglement? These are staples of science fiction, ways to bypass the light speed limit and travel faster than light. And yes, some of these concepts have basis in theoretical physics. Einstein's general relativity allows for solutions like wormholes that connect different points in space-time. Miguel Alcubierre proposed a warp drive metric that theoretically allows faster-than-light travel by warping space-time around a spacecraft. These are real physics papers, not just science fiction. But here's what people don't understand. Just because something is mathematically possible in general relativity doesn't mean it's physically possible in reality. Wormholes require exotic matter with negative energy density to keep them open. We've never observed exotic matter. It might not exist. The quantum field theory calculations suggest that if it exists at all, the amounts available are negligibly small. Creating and maintaining a wormhole large enough for a spacecraft would require more exotic matter than might exist in the entire universe. That's not an engineering challenge, that's a fundamental impossibility. Warp drives have the same problem. The Alcubierre metric requires negative energy to warp space-time in the right way. Same exotic matter problem. Plus, the energy requirements are absurd, even with exotic matter. Estimates suggest you'd need the mass energy equivalent of Jupiter or more to create a warp bubble for a small spacecraft. That's 27 kilograms converted entirely to energy. That's more energy than human civilization has used in its entire history by a factor of billions. And you need to deploy it in a specific configuration around your spacecraft. It's not just impractical, it's impossible for any civilization short of one that can manipulate the energy output of multiple stars. Quantum entanglement is often misunderstood as allowing faster-than-light communication. It doesn't. When particles are entangled, measuring one instantly affects the other, regardless of distance. But you can't use this to send information faster than light because the measurement outcomes are random. You can't control what result you get, so you can't encode a message. Entanglement allows for quantum cryptography and quantum computing, but not faster than light communication. Physics is very clear on this, so all the exotic proposals for faster than light travel either require physics we don't have and probably can't have, or they violate fundamental principles like causality. They're not realistic options. They're not engineering challenges that better technology will solve. They're fundamental impossibilities based on how the universe works. Now let me talk about another proposal, meeting aliens through their artificial intelligence. The idea is that advanced civilizations might upload themselves into computers, becoming post-biological AI consciousnesses. These AIs could be beamed across space as information, traveling at light speed as radio or laser signals, and reconstructed at the destination. This bypasses the problems of keeping biological organisms alive during long journeys. AI doesn't need air, water, food, or radiation protection. It doesn't age. It can be put into hibernation mode during transit and reactivated on arrival. This sounds promising until you think about what it actually means. First, we don't know if consciousness can be uploaded. We don't understand consciousness well enough to know if it's fundamentally tied to biological brains or if it can be transferred to silicon. This is one of the deepest unsolved problems in neuroscience and philosophy. We might discover that consciousness cannot be uploaded, that it's inherently biological in ways we don't yet understand. In that case, the whole proposal fails. Second, even if consciousness can be uploaded, transmitting it across light years as a radio signal faces the same problems as any radio transmission. The signal weakens with distance. It can be corrupted by noise. It takes years or centuries to arrive. By the time your AI consciousness arrives at the destination star, traveling at light speed, the civilization that sent you might be gone. Third, what would an AI consciousness do when it arrives? It needs hardware to run on. It needs energy. It needs materials to build bodies or interfaces to interact with the environment. Where does all that come from? You need to send instructions for building the necessary infrastructure, or you'd need existing infrastructure at the destination. If aliens receive your transmission, they need to build hardware compatible with your AI, assuming they can even decode your transmission and understand what you are. This is a massive coordination problem. You're essentially asking aliens to resurrect you in hardware they build, following your specifications. Would you trust them to do that correctly? Would they even want to? Fourth, even if everything works perfectly, even if your AI consciousness arrives and is reconstructed successfully, you still face the communication delay problem. You're now a human consciousness running on alien hardware 1,000 light years from Earth, or wherever you came from. You can't talk to anyone back home with less than 1,000-year delays. You're interacting with aliens who are so different from you that meaningful communication is difficult or impossible. And you can't leave because you're software now, not a physical being. You're trapped in the destination system. This is not the glorious meeting of civilizations. This is existential imprisonment in alien hardware, isolated from your origin civilization forever. So even the AI transmission proposal, which sounds like it bypasses many problems, actually just creates new ones while preserving the fundamental isolation that makes meeting aliens impossible. Let me now address the idea that maybe we don't need to meet aliens ourselves. Maybe we can meet their probes or artifacts. If civilizations can't travel far from their home systems, but they send probes, maybe we'll encounter those probes in our solar system. In fact, there was excitement recently about Oumuamua, the interstellar object that passed through our solar system in 2017. Some people speculated it might be an alien probe because of its unusual elongated shape and trajectory. Harvard astronomer Avi Loeb even suggested it could be a light sail pushed by radiation pressure. But follow-up analysis showed it's almost certainly a natural object, probably a comet or asteroid fragment from another star system. It shows no signs of artificial origin, no radio emissions, no unusual behavior beyond what natural objects can display. We've now detected a few interstellar objects passing through the solar system. All appear to be natural, no evidence of artificial origin. But suppose someday we do find an alien artifact in the solar system, an ancient probe sent millions of years ago that's been drifting through space. What would that tell us? It would tell us aliens existed millions of years ago in some star system within reach of wherever the probe came from. But it wouldn't tell us whether those aliens still exist. It wouldn't allow us to communicate with them because the probe is probably not designed for two-way communication. It's just observing and recording. And even if it could communicate, the civilization that sent it might be dead. We'd be communicating with a machine representing a dead civilization, learning about the past but not establishing contact with living aliens. So even finding alien artifacts doesn't solve the fundamental problem. It just confirms that aliens existed at some point, somewhere, which we already strongly suspected. It doesn't allow for meaningful contact or interaction. Now let me address one final idea. Maybe aliens will come to us. Maybe we don't need to figure out interstellar travel because more advanced civilizations will solve the problem and send representatives to Earth. This is the premise of most alien contact stories. Aliens showing up on Earth in flying saucers, establishing embassies, sharing technology. And yes, if aliens are out there, some might be more advanced than us. Some might have had millions of years more to develop technology. Maybe they've solved problems we can't. But they face the same physical laws we do. They're constrained by the speed of light. They need enormous energy for interstellar travel. They face the same biological incompatibility problems. Being more advanced doesn't mean you can violate physics. It just means you can do difficult things more efficiently. But if something is fundamentally impossible, no amount of advancement makes it possible. So advanced aliens, even millions of years more advanced, probably can't reach Earth any more than we can reach them. They're trapped in their star systems, just as we're trapped in ours. The fact that we haven't detected any alien visitors, despite decades of watching the skies, despite millions of UFO reports that all turn out to be misidentifications or hoaxes, despite intensive monitoring by astronomers and military, strongly suggests that aliens aren't coming here. Not because they don't exist, but because interstellar travel is prohibitively difficult even for advanced civilizations. In part 3, I'm going to talk about what this permanent isolation means for humanity and for our understanding of the universe. If we can never meet aliens, if the universe is full of intelligent life, but that life is forever isolated in separate star systems scattered across the galaxy, how should we think about our place in the cosmos? What does it mean to be alone in a universe full of others? And how should this knowledge shape our priorities and our future? Because accepting that we can never meet aliens, that we're permanently isolated on our one planet orbiting our one star, fundamentally changes what it means to be human and what we should be doing with our civilization. So we've established that the universe almost certainly contains many intelligent civilizations, possibly millions of them scattered across the galaxy and beyond, but that we can never meet them. The distances are too vast, the speed of light too slow, the energy requirements too extreme, the biological incompatibilities too severe, the temporal coordination problems too difficult. Every proposed method of contact fails when examined honestly. We are permanently, irrevocably isolated, not because we're the only intelligent life in the universe, but because the universe is structured in such a way that intelligent civilizations cannot interact. They exist in separate bubbles of space-time, each one confined to their home star system, each one looking out at the cosmos with the same longing and the same impossibility of reaching what they see. We are alone together, billions of separate consciousnesses scattered across the universe, all isolated, all wondering if anyone else exists, all unable to answer each other's calls. This is a profound realization that changes everything about how we should think about our place in the universe and what we should be doing as a civilization. Let me start with the most immediate implication. We need to completely rethink the Fermi Paradox. For decades, we've been asking, where is everybody? As if it's a genuine mystery that aliens aren't visiting us, aren't sending us signals we can detect, aren't building megastructures we can observe. But once you understand the barriers to contact, once you accept that interstellar travel and communication are effectively impossible, the Fermi Paradox disappears. It's not a paradox at all. It's exactly what we should expect. The universe is probably full of civilizations, but they're all trapped in their home star systems, just as we're trapped in ours. They're all broadcasting signals that are too weak to detect beyond a few hundred light years. They're all looking for others and finding silence. Looking for others and finding silence. They're all wondering, where is everybody? And the answer is, everywhere, but unreachable. This solution to the Fermi Paradox is often called the isolation hypothesis or the cosmic quarantine hypothesis. The universe didn't intend for civilizations to meet. The laws of physics that govern our universe create conditions where biological life can emerge, where intelligence can evolve, where technological civilizations can develop, but those same laws prevent those civilizations from ever interacting with each other. The speed of light is fast enough to allow causal interactions within planetary systems, but too slow for practical interaction between star systems. Gravity is weak enough to allow structures and life to form, but strong enough to trap civilizations in deep gravity wells that are expensive to escape. The universe is vast enough to contain many civilizations, but too vast for them to find each other. Everything is calibrated to produce intelligence in isolation. Why would the universe be structured this way? I don't know if there's a purpose, but I can tell you the consequences. Isolated civilizations must develop independently. They cannot rely on help from more advanced species. They cannot receive warnings about dangers they're approaching. They cannot benefit from the accumulated wisdom of older civilizations. Each civilization must figure everything out on its own, make its own mistakes, potentially destroy itself before learning wisdom. This is a harsh universe for intelligence. It gives you consciousness, gives you the ability to understand the cosmos, but denies you the companionship of others like you. You're forever alone with your thoughts, knowing that others probably exist, but being unable to ever meet them. Now, some people find this depressing. They say that one of humanity's greatest dreams is meeting aliens, learning from them, joining some kind of galactic community. And if that's impossible, if we're forever isolated, then what's the point? Why care about the universe if we can never interact with anyone else in it? But I think this perspective is wrong. I think permanent isolation, once accepted, can be liberating rather than depressing. Let me explain why. First, it means we're not missing out. There's no galactic community we're excluded from, no elder civilizations we're failing to contact, no cosmic wisdom we're missing because we're not advanced enough. Everyone is isolated. Everyone is alone. We're not failing at something others have succeeded at. We're all in the same situation. And there's a certain equality and dignity in that. We're not cosmic children waiting for adults to guide us. We're on our own, responsible for our own fate, as capable as anyone else of figuring things out, because everyone has to figure things out alone. Second, it means that human civilization is unique and precious. If we can never meet aliens, if Earth is the only world we'll ever experience, and humans are the only intelligence we'll ever interact with, then human civilization takes on absolute value. It's not replaceable. It's not redundant with alien civilizations elsewhere. It's the only civilization we'll ever have. Every human life, every human achievement, every bit of human knowledge and culture is unique in the accessible universe. We are the universe's way of knowing itself, at least in our corner of space-time. And that's extraordinary. That matters. That gives our existence profound meaning, even if we're cosmically isolated. Third, it means we can stop worrying about alien invasions or hostile first contact. This is actually good news. One of the concerns about broadcasting signals into space or sending out probes is that we might attract the attention of hostile aliens who would come to conquer or destroy us. But if interstellar travel is as difficult for them as it is for us, then we don't need to worry. They can't get here any more than we can get to them. We're safe in our isolation. We can explore and learn about the universe without fear that we're attracting predators. Fourth, it frees up resources. We can stop spending billions on SETI programs that will never find anything. We can stop planning for human missions to distant stars that will never happen. We can redirect those resources and intellectual efforts toward problems that actually matter, problems here on Earth and in our solar system, problems we can actually solve: climate change, poverty, disease, sustainable energy, artificial intelligence, safety, all the challenges facing human civilization right now. These are solvable problems if we commit to solving them. Meeting aliens is not. So accepting cosmic isolation allows us to focus on what's actually achievable rather than chasing impossible dreams. Now, let me talk about what this means for how we should think about Earth and our solar system. If we can never leave the solar system in any meaningful way, if we're confined here forever, then our solar system becomes our entire universe in a practical sense. Everything humanity will ever experience, everything we'll ever accomplish, everything we'll ever be happens here. In our solar system, orbiting our sun, this one medium-sized yellow star out of hundreds of billions in the galaxy. And that means we need to think very carefully about how we use this system, how we manage its resources, how we ensure our civilization can survive here for as long as possible. Because there's nowhere else to go if we mess this up. Let's start with Earth, because Earth is special even within our solar system. It's the only place where we can live without artificial life support. Every other location, the Moon, Mars, asteroids, the moons of Jupiter and Saturn, all require habitats and spacesuits and continuous technological support. But Earth provides everything we need naturally: air, water, food, comfortable temperatures, protection from radiation, appropriate gravity. Earth is not just our home. It's the only home we can have where we can walk around freely and breathe without machinery. This makes Earth extraordinarily valuable. If we ruin Earth, if we make it uninhabitable through climate change or nuclear war or environmental collapse, we lose the only natural habitat humanity will ever have. We could survive on Mars or the Moon in artificial habitats, but that's not the same as actually living freely in a planetary environment. It's the difference between being home and being in a hospital on life support. You can survive on life support, but it's not living in any full sense. So protecting Earth, maintaining its habitability, becomes absolutely critical when you accept that we're confined to this solar system. Earth is not just another planet, it's the planet, the only one where we can truly live. Every environmental problem on Earth becomes an existential issue because there's no backup planet. Climate change isn't just an inconvenience or an economic problem. It's a threat to the only natural habitat we have. We must solve it. Not because we should, not because it's the right thing to do, but because we must if we want human civilization to survive as more than a collection of people in artificial habitats depending on machinery to breathe. Similarly with biodiversity, Earth's ecosystems are not just nice to have, they're the life support system that makes Earth habitable. Forests produce oxygen and absorb carbon dioxide. Oceans regulate climate and provide food. Soil ecosystems enable agriculture. Pollinators enable plant reproduction. The web of life on Earth creates the conditions that allow us to exist. Disrupting this web, driving species extinct, destroying habitats. These aren't just environmental problems, they're existential risks, because if we break Earth's ecosystems badly enough, if we trigger collapse that we can't reverse, then Earth stops being habitable in the natural way that makes it special. We'd be living on a damaged planet dependent on technology to replace the natural functions we destroyed. So biodiversity protection, ecosystem preservation, sustainable resource use, all of these become critical when you accept that Earth is the only natural habitat we'll ever have. Now let me talk about the rest of the solar system, because even though we can't live naturally anywhere else, we can still use other bodies in the solar system for resources and for robotic exploration. The asteroid belt contains vast amounts of metals, water, ice, and other materials that could support space-based industry. The moons of Jupiter and Saturn have water, organics, and possibly life in their subsurface oceans. Mars is interesting for scientific research. The Sun itself is our power source for the entire system. There are resources and opportunities throughout the solar system, and we should use them. But we should do so primarily with robots rather than humans. Send robots to mine asteroids, to study the moons of Jupiter, to explore Mars. Bring resources back to Earth, or use them to build infrastructure in space that benefits Earth. Establish automated systems that don't require constant human presence and support. Humans can visit occasionally for specific purposes, but we shouldn't be trying to establish permanent colonies on Mars or the Moon for the reasons I've discussed in previous presentations. Those environments are too hostile for long-term biological survival. Better to have small research stations with rotating crews, like Antarctica, and do most of the work with robots. This maximizes the scientific and economic return from the solar system while minimizing the risk and cost of keeping humans alive in hostile environments. The solar system becomes our extended resource base and laboratory, but Earth remains our home. This is a realistic vision of humanity's future in space that's actually achievable with foreseeable technology and that delivers real value. Now let me talk about timescales. Because accepting cosmic isolation means accepting that we're here for the long term. If we can't spread to other star systems, if we're confined to this one solar system orbiting this one star, then our entire future as a species, however long that is, plays out here. How long can we last? The Sun will eventually die. In about 5 billion years, it will expand into a red giant and engulf Earth. That's our absolute deadline. But long before that, maybe 1 billion years from now, the Sun will have brightened enough to make Earth too hot for life as we know it. The oceans will evaporate. The greenhouse effect will run away. Earth will become like Venus. So we have somewhere between 1 and 5 billion years, depending on how you count, before Earth becomes naturally uninhabitable due to solar evolution. That's an enormously long time. 1 billion years is 3,000 times longer than complex life has existed on Earth. It's 3 million times longer than human civilization has existed. If we can survive for even 1% of that time, that's 10 million years, which is 30 times longer than our species has existed so far. So we have the potential for an extraordinarily long future, even confined to one solar system. But surviving for millions or billions of years requires solving problems we currently face. We need to become a sustainable civilization that can persist indefinitely on Earth's finite resources. We need to eliminate existential risks like nuclear weapons and runaway climate change. We need to develop the wisdom and governance capabilities to manage our power responsibly. We need to think on time scales of thousands and millions of years rather than quarters and election cycles. This is a profound civilizational challenge. Most human societies think short term. We plan for years or decades at most. We heavily discount the future, prioritizing immediate gains over long-term sustainability. But if we're going to survive in this solar system for millions of years, we need to fundamentally change how we think about time. We need institutions designed to function for thousands of generations. We need to preserve knowledge across potential civilizational collapses. We need to manage Earth's environment for the very long term, maintaining its habitability for as long as physically possible. We need to develop technologies and social systems that can persist indefinitely without depleting critical resources or creating catastrophic pollution. This is hard, possibly harder than interstellar travel would have been if it were possible. But it's achievable because it doesn't violate physics. It just requires wisdom and long-term thinking, which are difficult but not impossible. And I believe if we commit to it, if we accept that this solar system is our permanent home and we need to make it last, we can do it. We can create a civilization that endures for geological timescales. That's a worthy goal. More worthy than the fantasy of spreading across the galaxy, because it's actually achievable and it's what we need to do to survive. Now let me talk about what cosmic isolation means for science and knowledge. If we can never meet aliens, does that mean there are things we can never learn? Are there insights that only alien civilizations possess that we'll miss out on? I don't think so. Physics is the same everywhere in the universe. The laws of nature to another. Mathematics is universal. Logic is universal. Any civilization, anywhere, studying the universe will discover the same fundamental truths about how reality works. They'll have different perspectives, different ways of thinking about problems, different technologies and cultural contexts. But the underlying reality they're studying is the same reality we study. So, in principle, anything aliens know about physics or mathematics or the fundamental nature of reality, we can also discover on our own, through our own research. We might discover things in different orders or use different conceptual frameworks, but we're all studying the same universe, governed by the same laws. So cosmic isolation doesn't prevent us from understanding reality. It just means we have to figure it out ourselves, rather than being given the answers by more advanced civilizations. And honestly, that's probably better. Knowledge gained through your own effort is deeper and more meaningful than knowledge received from others. If aliens could hand us their physics textbooks, we might gain information quickly, but we wouldn't really understand it the way we understand things we discover ourselves. We'd be following someone else's path rather than forging our own. So being isolated forces us to do the hard work of genuine discovery, and that makes our knowledge more solid and more valuable. There might be some practical knowledge we miss out on. Aliens might have developed technologies we'll never think of, solutions to engineering problems that would be useful. But if the fundamental physics is the same, then in principle, we can develop the same technologies if we work at it long enough. It might take us longer without examples to learn from, but we're not fundamentally limited. We have billions of years to figure things out if we survive that long. That's more than enough time to explore all the accessible areas of technological possibility. So I'm not worried that cosmic isolation prevents us from advancing scientifically or technologically. We have everything we need: intelligence, curiosity, the scientific method, and billions of years to work. Now let me address what this means for meaning and purpose in human life. Many people find meaning in grand narratives about humanity's destiny, stories about where we're going and what we're becoming. For the past century, one of the dominant narratives has been about humanity spreading to the stars, joining a galactic community, becoming a spacefaring civilization. This narrative has inspired countless people, motivated young people to study science and engineering, provided hope that humanity has a future beyond Earth. If that narrative is false, if we're permanently confined to one solar system with no possibility of meeting aliens, does life lose meaning? Do we lose purpose? I don't think so. I think meaning comes from within, from the values and goals we choose, from the connections we make, from the experiences we have and the knowledge we gain. The scale of your impact doesn't determine whether your life is meaningful. A human life lived well, with love and curiosity and courage, is meaningful regardless of whether humanity ever leaves the solar system. And there's a kind of courage in accepting cosmic isolation. It would be nice to think we're destined for the stars, that we'll join galactic civilization, that we'll meet wise elder races who will guide us. But that's a comforting fantasy. The reality is harsher. We're alone, we're on our own, we have to figure everything out ourselves, and we have to make our own meaning in a universe that offers no external validation. That's hard. But it's also honest, and there's dignity in facing reality honestly, rather than clinging to comfortable illusions. We're not special in the universe. We're not chosen for any grand destiny. We're just one more intelligent species among probably millions, all isolated, all alone, all making their own meaning in their own corners of the cosmos. And that's okay. That's enough. In fact, I would argue that cosmic isolation makes what we do more meaningful, not less. If we could rely on aliens to help us, to save us if we make mistakes, to preserve humanity's legacy, if we destroy ourselves, then our choices would matter less. We'd have a safety net, but we don't. We're on our own. Every choice we make, every problem we solve or fail to solve, every value we uphold or betray has absolute consequences because there's no one else to fix our mistakes. We're writing humanity's story, and there's no editor, no backup draft, no second chance if we mess it up. That makes our choices matter enormously. Every generation is responsible not just to themselves, but to all future generations, potentially millions of years of human descendants, because there's no one else who will take care of them. It all depends on us, on whether we're wise enough and good enough to build a civilization that lasts. That's a heavy responsibility, but it's also empowering. We're not following someone else's script. We're not joining someone else's civilization. We're creating our own future, making our own meaning, writing our own story. And that story, however it unfolds, will be unique in the universe because every isolated civilization's story is unique. No one else will ever have exactly our history, our culture, our achievements and failures. We're one of countless experiments in intelligence scattered across the cosmos. And our experiment matters because it's ours, because we're living it, because the consciousness experiencing this moment right now is real and valuable regardless of scale or cosmic significance. Let me talk about how accepting cosmic isolation should change our priorities as a civilization. If we're never leaving the solar system, if we're never meeting aliens, then what should we be doing? What goals should we pursue? I think the answer is clear. We should focus on making life as good as possible for everyone on Earth, on preserving and enhancing Earth's habitability, on creating knowledge and culture, on exploring our solar system robotically, and on ensuring our civilization can persist for as long as possible. Let me break these down. First, quality of life on Earth. If Earth is the only place humans will ever live naturally, then making Earth a good place to live becomes paramount. That means solving poverty, hunger, disease, inequality, all the problems that make life miserable for billions of people. It means ensuring everyone has access to education, healthcare, meaningful work, and opportunities to flourish. It means creating societies that are just, free, and conducive to human well-being. These are achievable goals if we commit sufficient resources and political will. We have the knowledge and technology to eliminate extreme poverty, to feed everyone, to cure most diseases, to provide quality education globally. We just need to prioritize these things above other concerns, like military spending or luxury consumption by the wealthy. If we accepted that Earth is our permanent home and that making it as good as possible is our primary task, we'd organize society very differently. We'd value sustainability over growth, equality over hierarchy, long-term well-being over short-term profit. This isn't utopian dreaming, it's rational prioritization based on accepting our cosmic situation. Second, environmental protection and restoration. Earth's biosphere is the most valuable thing in the accessible universe from our perspective. It's the only natural system that supports human life without artificial assistance. We should treat it accordingly, with reverence and care, ensuring its health and resilience for as long as physically possible. That means aggressively addressing climate change, not gradually over decades, but as fast as physically possible. It means protecting and restoring ecosystems, allowing damaged forests and wetlands and coral reefs to recover. It means managing resources sustainably so they're available for future generations. It means treating pollution and waste as serious problems that threaten our long-term survival rather than as acceptable externalities of economic activity. If we accepted that Earth is our only home forever, we'd already be doing all of this. The fact that we're not shows that we haven't truly accepted our situation yet. Third, knowledge and culture. If we're isolated, if we can't learn from aliens, then creating and preserving knowledge becomes humanity's primary contribution to the universe. Every scientific discovery we make, every mathematical theorem we prove, every work of art we create, every philosophical insight we articulate, adds to the sum total of meaning in the cosmos. In our corner of the universe, we are the only ones doing this. The universe doesn't know itself except through us. Consciousness doesn't reflect on existence except through us. So expanding knowledge and creating culture is not just personally fulfilling, it's cosmically significant. We should prioritize scientific research, support arts and humanities, preserve cultural heritage, and ensure knowledge is transmitted across generations. These activities don't have immediate economic returns, but they have ultimate value because they're how intelligence justifies its existence. Fourth, robotic exploration. Just because we can't go ourselves doesn't mean we can't explore. We should send robots throughout the solar system and beyond, studying every planet and moon, analyzing every asteroid and comet, observing every star and galaxy we can detect. We should build ever more powerful telescopes to study the universe at all wavelengths. We should search for biosignatures on exoplanets, even if we'll never visit them. We should listen for alien signals, even if we'll never receive a response. All of this expands our understanding of the universe and our place in it. And understanding is valuable for its own sake, regardless of practical applications. We're a curious species. Exploration and discovery are what we do. The fact that we can't meet aliens doesn't diminish the value of learning about the universe they inhabit. Fifth, long-term planning and institutional development. If we're going to survive millions of years, we need institutions designed for that time scale. We need libraries and archives that can preserve knowledge across potential civilizational collapses. We need governance systems that can make decisions for the long term rather than just for the next election. We need educational systems that instill values of sustainability and long-term thinking. We need economic systems that don't depend on continuous growth. We need to encode wisdom into our institutions so that even if individual humans remain short-sighted, our civilizational decision-making can be wise. This is an enormous challenge, and we've barely started on it. Most human institutions are designed for decades or centuries at most. We need to design for millennia and millions of years. That requires entirely new approaches to governance, law, economics, education. But it's necessary if we're going to fulfill our potential as a species. Now let me address the psychological and emotional dimensions of cosmic isolation. How does it feel to know you're alone in the universe, that you'll never meet aliens, that you're confined to one star system forever? For some people, this feels claustrophobic, limiting, depressing. The universe is so vast and we occupy such a tiny portion of it. We're like someone locked in a single room in an enormous mansion, able to see the other rooms but never able to visit them. That's frustrating. But I think this perspective can be shifted. Yes, we're confined to one star system, but that star system is enormous by human scales. The distance from the sun to the edge of the Oort cloud is about 1 light year, about 10 trillion kilometers. That's vast. There are probably trillions of comets and asteroids in the outer solar system that we've never seen, that no human will see for thousands of years. The solar system itself is an enormous territory to explore and use, and we've barely started. And Earth itself is extraordinary, There are ecosystems on Earth we don't fully understand, depths of ocean we've never visited, organisms we haven't discovered. Human culture is endlessly complex and varied. Human psychology and consciousness are profound mysteries we're only beginning to investigate. Art and literature and music offer infinite possibilities for expression and experience. Mathematics and physics have depths we'll be exploring for millions of years. There's more than enough on Earth and in our solar system to occupy human curiosity and creativity for our entire future as a species. We're not confined to a small space. We're inhabiting a rich and complex world as part of a rich and complex star system. The fact that we can't visit other star systems make our situation impoverished. It just means we need to appreciate what we have rather than always longing for what we can't reach. There's a certain peace that comes with accepting limitations. When you stop struggling against impossible barriers, when you stop wasting energy on unachievable goals, you can relax and focus on what's actually possible. We can stop worrying about whether we'll ever get to the stars and start focusing on making our home system as good as it can be. We can stop searching desperately for alien signals and start appreciating the intelligence and consciousness we already have access to in other humans. We can stop feeling inadequate because we haven't achieved science fiction dreams and start feeling proud of what we have achieved. We've figured out the basic laws of physics. We've decoded the human genome. We've created art and literature and music that moves the soul. We've built a global civilization spanning an entire planet. Those are extraordinary achievements. The fact that we're confined to one star system doesn't diminish them. Now, let me talk about one more implication of cosmic isolation that I find profound. It means that every intelligent civilization in the universe is facing the same fundamental challenges we face. Aliens, wherever they are dealing with climate change on their worlds, or have dealt with it in their past. They're managing scarce resources, balancing individual freedom with collective needs, deciding how to govern themselves, grappling with the ethical implications of powerful technologies, trying to ensure their survival for the long term. They face all the same problems because these problems are inherent to being an intelligent technological species on a finite planet. And they're solving these problems, or failing to solve them, entirely on their own, just as we are. There's a kind of universal struggle that all intelligence shares. The struggle to survive and thrive despite being mortal, finite, limited beings in a vast and indifferent universe. This means that our struggles matter not just to us, but cosmically. When we solve a problem, when we figure out how to manage some aspect of civilization sustainably, we're not just helping ourselves. We're demonstrating that it's possible, even if no one else ever knows. We're proving that intelligence can overcome challenges. And when we fail, when we destroy ourselves through war or environmental collapse or some other catastrophe, we're demonstrating failure, proving that the particular path we took leads to extinction. Every civilization is running this experiment independently, all across the universe, all isolated from each other. Some are succeeding, maintaining their civilizations for millions of years, creating lasting wisdom and beauty. Others are failing, destroying themselves before reaching maturity. The universe is full of these independent experiments in intelligence, each one unique, each one mattering to those who live it, each one contributing to the cosmic statistics of whether intelligence tends towards survival or extinction. We don't know which category we'll fall into. We're still very young, only a few thousand years into technological civilization. We have enormous challenges ahead of us, but we have the potential to succeed, to become one of the civilizations that survives for millions of years, that creates lasting value, that makes consciousness worthwhile. Whether we achieve that potential depends entirely on us, on the choices we make in the coming centuries. Will we be wise enough to solve climate change? Will we be mature enough to eliminate nuclear weapons? Will we develop AI safely? Will we learn to think long term? Will we create just and sustainable societies? These questions will determine our future. And no one can help us answer them because we're alone. But that's okay. We have everything we need: intelligence, knowledge, resources, and billions of years ahead of us if we don't destroy ourselves first. Let me end with a thought about meaning and consciousness in a universe of isolated civilizations. In such a universe, every pocket of consciousness is precious because it's fundamentally alone. The conscious experience happening in your mind right now, the qualia of color and sound and emotion, the sense of being someone, of experiencing reality from a particular perspective, that's extraordinary. And it's happening in millions of other minds across Earth right now. Each one unique, each one a universe of experience. And probably it's happening in billions of minds across the galaxy. Alien minds experiencing alien qualia, thinking alien thoughts, feeling alien emotions. All of these pockets of consciousness are isolated from each other. You can never directly experience what it's like to be someone else. I can never directly experience your inner life. Humans can never directly experience alien consciousness. We're all fundamentally alone in our subjectivity. Each one an isolated island of experience. But we can communicate. We can share information, express ourselves, create art and literature that conveys something of our inner experience to others. We can build civilizations that allow millions of conscious beings to cooperate and support each other. We can create meaning together even though we can't share consciousness directly. And that's beautiful. That's what makes consciousness valuable despite its isolation. We're alone, but we can connect across the barrier of separate minds. We can create shared meaning even though we can't share experience directly. Humans do this with each other on Earth every day. We build relationships, communities, civilizations, all based on communication across the barrier of separate consciousness. And in principle, if we could somehow communicate with aliens despite the distances and delays, we could do the same across the barrier of separate species and separate worlds. We can't because the distances are too vast. But the theoretical possibility is there. The recognition that all consciousness shares something fundamental. The fact of being, of experiencing, of mattering from the inside, even if we're alone from the outside. So in a universe of isolated civilizations, consciousness still matters. Experience still has value. Life still has meaning. We create that meaning through our choices, through our relationships, through our efforts to understand and improve reality. We're alone, but we're not without purpose. We're isolated, but we're not meaningless. We're confined to one star system, but we're not imprisoned because we never expected to leave, and we have everything we need right here. We were never meant to meet aliens. The universe is structured to keep civilizations separate. And that's not a tragedy, it's just reality. A reality we can live with, even flourish in, if we accept it honestly and build our civilization accordingly. Thank you for listening. Thank you for thinking through these difficult truths with me. And thank you for being part of humanity's experiment in intelligence, one of countless such experiments scattered across the cosmos, all alone, all meaningful, all contributing to the universe's ongoing exploration of what consciousness can